Hi everyone, I'm Nitin. I'm currently a data scientist with Swiggy, and I've been there for last 1.5 years. And today I'm going to talk about some of the experiments we have done with food recommendations, food discovery, and in terms of experiments, I'll talk about some of the insights, interesting insights, and I'll also talk about the challenges or the lesson learned in the process. So I hope it will be interesting talk because just before a lunch, it's kind of a bad timing, I would say. So just quick show of hand, how many have you actually ordered from Swiggy? Wow, good marketing, I guess say. So I think I think people are aware of Swiggy and they do use regularly. But I think just for completeness, this is what Swiggy is, I guess. It's mostly these three major players that actually drives the entire ecosystem. You have millions of customers, you have thousands of restaurant partners, thousands of delivery partners, and any problem that you're talking about, if you're thinking about just from the one player, it's actually going to impact the other two. So if you're thinking from the discovery and relevance problems, and you're not thinking about restaurant as well as the delivery executive or the entire ecosystem, it's not going to solve the problem. So at the same time, you have a lot of the delivery side of stuff like predicting the estimated times for the delivery, how can we batch the orders, how we can actually do the best assignment possible for the given order. All these problems are pretty tricky, and I think today what I'm going to focus on is the first part of the story where I'll focus on the discovery as well as the recommendation side of the things. So let's take a step back and just formally define what is a recommendation system. So I think the idea of a recommendation system is just to come up with a utility function even in the constrained environment like serviceability and availability. If you have a list of items, can you define this utility function that predicts the likelihood of a given customer and what's he going to like or what's he going to buy from the serviceable option. So, and when I talk about items in this context, it could be anything. In context of movies or in context of Netflix, it could be movies. In context of, let's say, Spotify, it will be the songs. And in the context of Swiggy, it is, one is the restaurant first view where you have we have the home feed. You have a lot of recommendation going through on the home feed. And then you also have some of these inline collections where those collection has been actually cut through the specific filtering criteria. And then you have some of this discovery widgets where you can actually click on just pure vegetarian restaurant, and those are also sort of personalized for your taste. Now we are also venturing into more of an item first world where in Bangalore at least we have released this new property called Dish Discovery, where the idea is, I think if you can, from your historic behavior or from your implicit feedbacks, if you can predict what is the main anchor dishes that you like, and if I know that you generally like pizzas versus, let's say, biryani, if I show you a beautiful collection or a story about those pizzas, rather than just you actually driving through multiple menus and then deciding what is the best pizza for you, it's actually a great experience. So we are venturing more from this to this, and I think in the end it will be more of a generation of the entire app rather than just focusing on a specific list or a specific collection. We also have some recommendations at menu. So we do recommend what are the best sellers, what are the typical sold items in the recommended sections. And also we have a traditional cross-sell where you have a typical association rule mining based algorithm where, but it's still smart enough to understand that if you have already ordered a main course, then I'm sure that you're not going to add one more main course. So it will suggest you some of the drinks or the dessert place. If you take the abstract idea of a recommendation system, it actually sort of a matchmaking between customer and what you're trying to sell. So in context of Swiggy, the items will be either restaurant first thing or it will be the exact food item, and in some cases it could be the entire meal itself. I think the secret ingredients is to understand your customer, and if you can understand your catalog or the food items very well. If you can solve these two, then I think you can do the matchmaking much better. So from the customer point of view, you want to understand what is the taste profile of this customer, whether he's a vegetarian, whether he's a non-vegetarian, what kind of time slot he generally orders, whether he orders for family, whether he orders for a home or a working lunch. He generally like healthy stuff, or he's focusing on, let's say, the speed. Similarly, you want to understand from the restaurant view as well, that what generally this restaurant means. Is it a taste profile that matters of that restaurant, what it sells? Is it like the cuisines or the dish that defines that restaurant? Or is it the price points or the CFT of that restaurant that talks about? So if you understand these two parameters, then I think it will be always additional features to the conventional models. Now still, the big question is, what is so unique or so niche about these recommendation? Because recommendation systems are not, this is not the first company that are working on recommendation system, right? So it has been solved across industries. There are examples where people have solved it in a way that everybody experiences the best possible recommendation that they have. So I think one of the major or the most important aspects that actually differentiates Swiggy from some of the other recommendation systems are these major factors where I think any hyperlocal business adds a lot more complexity to the systems. We are always constrained by the serviceability or the availability of our system. We do have restaurant stress or the entire stress on the entire ecosystem as well. And people do care about different elements like speed, which are not there in the traditional recommendation system. So think about this, right? I know you like pizzas and you have a very specific joint that you really love. Now, for some reason, it's not available. So I think, and that happens quite a lot in terms of Swiggy. Then what will be your the most relevant substitute to that? And that's where I think the serviceability constraints are very important in our system. So we have to think about the larger serviceability and availability rather than just looking for a specific customer. Restaurant stress is one of the other angle where, for example, a restaurant like Truffle is getting a lot more orders. And it's really in the stress, and at the same time, people keep on ordering from that, and suddenly you have a lot more orders driving towards that, and you start pushing a lot more demands towards that same restaurant. What will happen? I think eventually this restaurant gonna fail, and they will not be able to deliver the promises that they have made. And it will be very bad for the entire ecosystem. So we do have some of these real-time models that actually gives you the restaurant factors like stress, the prep times, and the other things in the real time. And if your recommendation system can actually take some of these inputs and do some of the demand shaping based on these things, it will be always helpful for the last consumer. And people do care about speed in the online food delivery world. So faster options should always get some level of prevalence. Now the other factors that I'm talking about are not very specific to Swiggy, and it is very much very hard choices when you have to design a recommendation system. So you generally like, let's say, a biryani, or I mean, in the 99% cases, you generally ordered biryanis in the past. Showing all the biryanis placed in the world, is it a good recommendation? It might be an accurate recommendation, but there has been proven examples where adding some level of diversity into your recommendation system always helps. So I would still go for getting some level of diversity with getting more Chinese points, or adding some level of Italian place into your listing or in the home feed. Discovery versus repeat is also one other option, where in general content related websites like news websites or even your Netflix or Amazon's, where I think there is a new original that has come on the Netflix. So they want to make sure, I mean, hopefully people will not, once you have finished that original, you will not keep on going on for the same original again and again. Now in the context of food delivery, you still prefer the restaurant that you have already ordered. So the repeat behavior is much much more important in the context here, right? So showing just the restaurant that you have already ordered, maybe the top 10 restaurant that you have keep on ordering from, is it a good recommendation? Oh, definitely yes. I guess, but still there should be a balance between how much we want to do explore versus the exploit. So I think this is again one of the tricky or the differentiator that we see across the industry. Freshness versus stability is another angle where you want to see that the recommendation you are getting on day to day, if they keep on changing very rapidly, it doesn't give you the notion that you are not able to understand why it's coming. So the explainability or the scalability also has a significant importance. At the same time, freshness is also matters. So if you like pizzas and the new pizza place that really excites you is not there in your home feed, gonna hurt your recommendation. Serendipitous is something I would say is kind of a definition of discovery, where some of these quotes from CNN, they talk about that this is more of an end of era of search, where you have explicit query, you're looking for a pizza and get the pizzas. Now the real discovery comes when a rare items actually finds you, and that surprises you. So the same case, let's say in the Netflix, when an original that you feel that you started watching and you feel how these guys are able to get this, or in the case of song, that rare song, that long tail that gets you, then only you feel that this is the real discovery. So the same context, if an Indian dessert that you feel that whether it's available or not on Swiggy, and that finds you, that would be something really magical, right? For any recommendation system, you need a lot more data, and these are the different variety of data set that we are having. We capture a lot of interaction on the app as well on the website. We do have orders data or a typical transactional data. We do have a very rich image data, which is very specific to the Indian foods, and which is sort of labeled as well for the specific categories. And you also have this other meta enrichment like dish families, cuisines, which we have sort of generated. And we also capture a lot of unstructured data where if you generally order and then you ask for certain type of instructions, as well as in the rating space where we generally capture the rating data as well and also ask for a feedback. A lot of these things has been used for generating the different recommendation system. Now in recommendation, these are the two major philosophy. One is more about if I can figure it out, who are the customers like you? And this is pretty much the philosophy of collaborative filtering. The other one is more on the generally people like similar items. So if you can define the similarity very nicely, then you obviously can do better recommendations. And that comes from the content side of the thing. Now collaborative filtering, I think eventually you want to build this customer item matrix. In case of this, it could be either restaurant, cuisine, category, or dish. And then you have, and some of these methods are defined for explicit data like ratings. And coming from Netflix challenge, where the idea is to predict those blank boxes, and if you can predict the rating of that, then it will be sort of a good recommendation. You just sort the recommendation based on the ratings. Now, I think Stephen Randall or Korean, they actually defined some of the methods for, some of the similar methods of matrix factorization for implicit data. And if you want to use this kind of implicit data like orders, menu widgets, search, and all these things, it's actually gonna kind of much fulfilling, because there are specific papers where they talk about generating the explicit data is much more costly, as well as it has its own bias. While if you use the implicit data, in many cases, it has actually outperformed the explicit data. So we tried out traditional matrix factorization methods like SVDs, ALS, and we also did a few experiments with learning to rank. And even in that, we added some of these customer features as well as the content feature as a features. And then that actually improved the performance of the model. Now, the problem with those methods of collaborative filtering is, one is a very standard cold start problem, and the other one is actually, in some cases, it's biased by popularity. So, idea was that how can we overcome these things, right? So that the traditional methods that actually are the solution for that are the content-based method, where you're trying to define this notion of similarity, and in the case of Swiggy, how to define this. So generally the content platforms like news and other websites, they have a lot of meta, like news articles, they have maybe the titles and the genre in case of movies. So you take that, you build a nice vector out of it, and then you do some level of similarity calculation. Now in case of Swiggy, we could have done two ways. One, okay. So we could have done, I think, either go by the meta that restaurant partners or the customer, the items we have, or we could have done something of our own. So what we did, we actually take the order data at a restaurant level, create a dummy document, and then build a sort of a topic visualization out of this. And somehow the demo is not working, but if you click on one of the specific topic, this actually captures the notion of the entire catalog what we have in Swiggy. So if you zoom out and zoom in into one of the topic, it talks about whether it's a biryani thing or maybe a South Indian thing. So the idea is to project your restaurant into this, and then you will have a decent vector out of it, and then you can actually calculate the similarity notion. Now it's again a more of a restaurant first kind of recommendation. And this is how it will look like in picture, right? So you will have some level of notion for similarity, and if you have already ordered from, let's say, truffle, there is a good chance that cafe itself will be there on your listing. You can have a restaurant first view based on the previous method, but still, if you want to do the recommendation at item level, you have to know what is the standard taxonomy for an individual item. So you have to differentiate between somebody calling pizza as main course versus somebody is calling maybe a Italian kind of thing. So we define the standard taxonomy, and these are the standard enums or the standards enums classes that we have defined. And then we build some level of supervised model. We have metadata related to some of these items, which is either in terms of item names, description, recipes. And in some cases, we also have the images, so we did some level of image classification. Once you have this kind of set, then it empowers you to do something that I was talking about in the initial slides, where once you can filter your data on the cuts like a dish, cuisine, and all, you can again go back to something like this, and then you can create this matrix, and then you can predict what are the most relevant cuisines or the dishes for you. I'll just skip the word embedding part, but I think this is so far the journey so far, and where we have done a lot more work on the collaborative plus content-based, and use ensemble of these two to generate some of the prediction, which is currently the state is somewhere on the hybrid as well as on the learning to rank part. While we are also looking into DNN-based methods where generating the item embeddings, product embeddings, or the restaurant embeddings are obviously an open area. And also deep collaborative filtering and RNN-based methods to generate the recommendation at a session level. So can you capture the real nuances on a specific session instead of just relying highly on the history? And the final slide actually talks about the journey of the Swiggy from the delivery or discovery platform. So here, currently we highly rely on our home feed and some of the initial personalized collection. We are moving towards a lot more collections, actually catered towards an anchor theme, and then slowly moving towards the generation of the entire app, where a lot of the personalized, like all the different collection will be personalized towards your taste and slots and even the other contexts. And finally, if you do some level of real-time adjustments to make it much better. I think we are done. Okay. So this is the team that we have, and I think I'm available for the question.
We have some time for questions.
Hello.
Hey.
Hey.
Okay, yeah, I have one question.
Hello.
Hello, yeah.
Yeah, go ahead.
Yeah, so My question is, when you are showing, when you are recommending restaurants or dishes, what is the objective function you are maximizing for? Is it just the relevance for the user, or like
Got it.
revenue generated for Swiggy, or is it a mix of these things, or?
Yeah, I think
What?
so. Definitely we are constrained by some of the other factors like serviceability and other. So if our overall stress levels are decent, so we have a way of identifying what is the stress for Swiggy, and if that suffices, then we are chasing the relevance as a major proxy. And if that is not the case, let's say it's raining or it's we are not in the best of supply, then we degrade our things and then we just look for I think a general availability. So the idea will be to optimize the entire system based on the efficiencies rather than just going for relevance. But in normal context, which is where there is no stress, there is no specific constraint, generally the focus is always the relevance. But we do try it out when we talk about L2R or learning to rank method, where you can actually induce some of these other constraints into your objective functions. So we tried out demand shapings towards certain things like fasters, and in case of certain restaurant, you should not demand shape, or you should demand shape in a much more holistic way. So you do need to consider the restaurant view as well as the entire Swiggy as a platform.
Okay.
A question here.
Yep.
So just want to understand what is your implicit signal, and the second question is, are you still using ALS for the factorization?
No, so ALS was the first one, but I think the one I was talking about is coming from this guy, Stephen Randall. I think it's a very known publication, and there you're using a RAP loss with, effectively it's a learning to rank method where you're doing a pairwise loss, and ALS was obviously the start, kind of. Sorry?
I have one question about learning to rank. So which model forms are you using within learning to rank? There are many sub-models within that, right? So
Can you repeat that?
by learning to rank, which particular model forms do you mean? I mean like Lambda Mart or like RankNet, or what type of models are you using?
I think currently the models are pretty much on the matrix factorization based methods, or some notion of these content based methods. I think I didn't
My
get.
question is about the learning to rank models.
Yes.
Which you mentioned that you are exploring or you have been putting it in place.
I think we are just exploring the pairwise thing. I think you're talking about, I think maybe the
Pairwise, gotcha.
list-wise methods. Okay. So I think overall, if you see the literature also, the pairwise methods are there for a long time, and they have been proven because that they are working for certain. List-wise still, I think I would say not at the level where some of these, they are for the research and other thing, but I haven't come across a very standard method that has been widely used. But it's still, I think that is the direction where people are heading.
Okay. One more question on the data. So when you're estimating any models like this, and not forget about the loss function.
Yes.
You also need to think about what data do I use. Do I use those who just browse around but don't order, but also those who have ordered something, so for them the relevance will be different.
Sure.
So there'll be these issues around, the nature of search will be different, and those who are just browsing will just click a ton of things and then go, but then they don't book.
Sure.
Right? So have you looked into this? What's your opinion about it? Did you try to account for all those in modeling?
I think the implicit data that we use is somewhat listed on this one. So there is a long list, but I think the idea is, I think if you have attended the talk from Sailesh, I think yesterday, he was also talking about you have tons of implicit data. How you actually smartly take that and create a meaningful supervised level or meaningful implicit feedback is something that we should think about. So though somebody has visited a menu, but he never actually ordered from that specific restaurant, should be ideally penalized. At the same time, if somebody is spending a lot more time on menu, we should give it a boost, right? Or if somebody has already added to the cart. So the idea is that he actually likes that restaurant, he liked the recommendation, but he maybe hung on some other factors like offers and all. So you need to give some level of weightage to some of these things. And that's where I think the real data will lie, rather than just throwing everything at one go.
Yeah, so
Sorry.
Last question. My question is rather simple. How do you evaluate your recommendation system, whether it is working or not?
So
Is
that's
it,
a very standard NDCG metrics, and so at least at a modeling step, you can. So if you think about these problems, they started with a traditional metrics of rating prediction, and if you can get the rating prediction right and do a basic like a root mean square error on that, that was the initial start. But then gradually people started hinging towards can you do AUC? So if you can think about it, think it as a more of a classification model, and then you can predict, like then you can at least on your in-sample data you can calculate AUC and all. But when you are running this in the production, like maybe a AB system or something, then the typical matrix will be either NDCG, or a more conventional method that we talks about in a larger group is how many people are actually ordering from the first 15 what you saw, or how many people are actually not ordering from search. So currently, if our orders, 60% of our orders, let's say, come from the feed, and 30% people actually come from search, if you can decrease, so ideally that if your recommendations are very good, people will not go for search, though there is a behavioral thing as well, but if you can reduce that, then there is a good potential that whatever you're recommending to the customer is a proxy like that you're getting right. So overall, at an online level, you can always see the click-through at a funnel of from the listing to the cart. So that is some of the business objective or business metrics, but you can always define it in much more mathematical terms in terms of NDCG or mean reciprocal ranks and all.